For decades, the Bermuda Triangle has stood as a chilling symbol of fear, fueled by countless myths and haunting tales of inexplicable disappearances across the open sea. But when we peer through the focused lens of modern science, do these ghosts truly exist, or are they merely phantoms born from unexplained geographical anomalies? This legendary stretch of water has claimed more than its fair share of sailors, but the truth hidden beneath the waves is far more complex than fiction. From the vanishing of Flight 19 to the silence of the USS Cyclops, every mark on this map tells a story of tragedy and a deep mystery. Legends speak of magnetic anomalies that drive instruments mad, leading pilots and captains into a void where time and direction seem to lose all meaning and purpose. However, today's researchers are using advanced technology to strip away the folklore and replace it with hard data, revealing the true nature of this volatile maritime region. We are embarking on a journey to decode the physics of the triangle, moving past the superstition to understand the real forces at work in the deep. Is it possible that the answers have been right in front of us, hidden in the very chemistry of the water and the structure of the atmosphere? The sea does not keep secrets easily, but the patterns of history provide clues that allow us to reconstruct the final moments of those who were lost. As we dive deeper into the evidence, we must ask if the reputation of the Bermuda Triangle is a reality or a product of our collective imagination. Science is the key to unlocking this door, providing a rational explanation for the phenomena that have terrified the world for over 100 years of history. Join us as we explore what scientists have actually found in the heart of the Bermuda Triangle, where the legends finally meet the cold, hard facts. The legend truly began in 1945 with Flight 19, a routine training mission that saw 5 Navy bombers vanish into thin air without a single trace left. The last radio transmissions described a world where the ocean looked strange and the compasses failed, sparking a mystery that would capture the global public's imagination. Decades earlier, the USS Cyclops disappeared with over 300 souls on board, leaving no wreckage and no clues, further cementing the area's deadly and dark reputation. However, when we analyze the numbers provided by the U.S. Coast Guard, a very different story begins to emerge from the vast ocean of statistical data. Records from Lloyd's of London, the world's leading insurance market, prove that the rate of accidents here is no higher than in other busy shipping lanes. The high volume of traffic in this region naturally leads to more incidents, making it a matter of probability rather than a curse from a supernatural source. Other regions, like the Dragon's Triangle near Japan, share similar reputations, yet they are all subject to the same laws of physics and human error. The combination of heavy traffic and unpredictable Caribbean weather creates a perfect storm of conditions that can easily overwhelm even the most experienced maritime crews. Every disappearance can be traced back to a logical sequence of events, yet the myth persists because humans are naturally drawn to the allure of mystery. By deconstructing these historical events, we find that many reports were exaggerated or omitted crucial details that would have explained the incidents quite simply. Finding the wreckage is often the final nail in the coffin for these legends, showing the physical reality of a crash rather than a mystical vanishing. Modern exploration continues to find the remains of those lost, providing closure and proving that the sea does indeed leave behind evidence of its power. As our technology improves, the number of mysteries in the Bermuda Triangle decreases, leaving us with a clearer picture of our own human vulnerabilities. Human error remains one of the primary causes of maritime disasters, often exacerbated by the extreme environmental factors found within this specific geographic region. While the legends focus on the unknown, the reality is built on the known risks of seafaring, which have been managed but never fully eliminated by technology. Understanding this balance between myth and reality allows us to appreciate the true scientific wonders that the Bermuda Triangle actually has to offer us today. One of the most fascinating scientific theories involves methane hydrate, a frozen gas trapped under the seabed that can escape in massive, violent underwater bursts. When these methane deposits are disturbed, they release enormous clouds of bubbles that significantly reduce the density and buoyancy of the surrounding seawater in seconds. For a ship caught in this fizzy water, the result is catastrophic. The vessel loses its ability to float and sinks rapidly like a stone falling. Laboratory experiments have successfully replicated this effect, proving that a high enough concentration of gas bubbles can indeed take down a ship without warning. Similar craters have been found in the Barents Sea, providing geological evidence that these massive gas blowouts are a real and present danger in some oceans. Beyond sinking ships, methane gas can also rise into the air, potentially affecting aircraft engines by altering the oxygen levels required for proper fuel combustion. If a plane flies through a dense cloud of methane, the engine could stall or ignite, explaining some of the more sudden and violent aerial disappearances reported. The geological activity in the Bermuda Triangle makes it a prime candidate for these types of events, though they are rare and very difficult to predict. By studying these fire ice deposits, geologists are learning how the shifting of tectonic plates can trigger the sudden release of these deadly gas reservoirs. These landslides can happen in the blink of an eye, turning a peaceful sea into a boiling trap that swallows everything on the surface above it. The sheer speed of such a sinking would leave no time for the crew to send a distress signal or deploy lifeboats for their survival. As the ship descends into the abyss, the immense pressure of the ocean ensures that very little remains for search teams to find in the aftermath. This physical explanation provides a terrifyingly plausible scenario for many ghost ship sightings where vessels were found empty or vanished completely without a trace. Science allows us to measure these forces, turning a supernatural mystery into a study of fluid dynamics and the volatile chemistry of our planet's crust. We are now mapping these dangerous zones with precision, identifying where the crust is thin and the risk of methane release is at its highest. The physics of a single bubble is simple, but the power of millions acting together is enough to rewrite the history of any ship's final voyage. These plumes are like invisible killers, silent and swift, leaving nothing behind but a temporary disturbance on the surface of the rolling Atlantic waves. Engineers are even looking at how to design ships that might survive these density changes, though the scale of the energy involved makes it nearly impossible. At its core, this is a story of how the very foundation of maritime travel buoyancy can be undermined by the Earth's own internal and restless geological processes. The methane theory is a powerful bridge between the impossible and the probable, grounding the legend of the triangle in the reality of our planet's behavior. While it doesn't explain every incident, it provides a crucial piece of the puzzle, proving that nature's own traps are far deadlier than any ghost. Recent satellite imagery has revealed another atmospheric anomaly: strange hexagonal clouds that act like air bombs, with enough force to cause massive destruction below. These unusual formations create localized blasts of air that descend from the sky and strike the ocean with the power of a localized hurricane-force wind. Reaching speeds of over 170 miles per hour, these downbursts can easily flip ships or force aircraft into a terrifying and fatal dive. When these air bombs hit the water, they generate massive, steep waves that can appear out of nowhere, catching even the most vigilant crews off guard. For a pilot, flying into one of these downbursts is like hitting a brick wall made of air, followed by a sudden loss of all lift. The speed and intensity of these events leave virtually no time for recovery, turning a routine flight into a struggle for survival in a matter of seconds. Meteorologists are now using high-resolution radar to track these events, finding that they occur with surprising frequency in this specific part of the Atlantic. The combination of these winds and the resulting rogue waves creates a maritime environment that is among the most dangerous and unpredictable in the world. This is pure physics at work, the interaction of warm and cold air masses creating a vertical force that few structures are designed to withstand successfully. By understanding the mechanics of these clouds, we can finally explain many of the sudden disappearances that were previously attributed to the supernatural or aliens. Even in the age of sail, these events would have been lethal, explaining why the triangle has been feared for as long as humans have crossed it. Modern forecasting is helping ships and planes avoid these zones, but the ocean's vastness means that some pockets of danger will always remain hidden from view. We are learning that the atmosphere is just as dynamic as the ocean, with its own currents and waterfalls of air that can be incredibly destructive. The air bomb theory provides a logical, science-based explanation for why wreckage is rarely found. The forces involved tend to disintegrate vessels upon their impact. Once a plane hits the water at high speed, it fragments into tiny pieces that are quickly scattered by the powerful and swift-moving ocean currents. The ocean then acts as a giant recycler, burying the evidence under layers of sand or sweeping it away into the deep canyons of the Atlantic. It is a reminder that the most dangerous things in nature are often invisible until the very moment they strike with their full and lethal force. Science is our only defense, providing the warnings necessary to navigate a world that is governed by the laws of physics and atmospheric pressure. Every data point we gather brings us closer to a future where the Bermuda Triangle is just another part of a well-understood and mapped world. The legend is being replaced by knowledge, and while the fear remains, it is now tempered by a deep understanding of the natural world's power. As we move forward, we realize that the magic of the triangle was always just a series of physical events waiting for us to decode them. The Gulf Stream is essentially a massive, powerful river within the ocean, moving more water than all the world's surface rivers combined through the Atlantic. This current acts as a giant conveyor belt, capable of carrying wreckage and debris hundreds of miles away from an accident site in mere hours. When a ship or plane goes down in this current, the X on the map where it vanished is often far from where it eventually rests. This rapid movement is one reason why search and rescue teams often find nothing but empty water, as the evidence is literally washed away by the sea. Directly within the Bermuda Triangle lies the Puerto Rico Trench, the deepest part of the Atlantic, reaching depths of over 27,000 feet below. Anything that sinks here is likely to fall into these deep chasms, where it is beyond the reach of almost all modern recovery and exploration technology. The combination of the fast current and extreme depth creates a perfect disappearing act for any vessel unfortunate enough to meet its end here. As wreckage slides into the trench, it is often buried by underwater landslides or hidden in crevices that have never seen the light of the sun. Scientists are using sonar to see through the darkness, but mapping such a vast and complex area takes years of painstaking and very expensive work. Every mission reveals a landscape as rugged and diverse as any mountain range on land, filled with potential hiding spots for the lost ships of history. The geology of this region is constantly changing, driven by the massive forces that shape our planet's surface over millions of years of geological time. These geological features can also trigger small tremors and shifts that further complicate the maritime environment, adding another layer of danger for sailors and pilots. While not as dramatic as the legends suggest, small magnetic variations do exist, and they can be enough to confuse a navigator who isn't paying attention. The Gulf Stream's power is such that it can create its own weather patterns, including sudden fogs and squalls that blind ships and aircraft without warning. Fighting against this flow is a constant struggle, requiring more fuel and more vigilance than sailing in the calmer waters of the open Atlantic Ocean. The current is a global force, connecting the Bermuda Triangle to the rest of the world and ensuring that nothing stays in one place for very long. For centuries, this ocean river has been both a highway for trade and a graveyard for those who underestimated its incredible and relentless speed and power. The secrets of the trench are being revealed one frame at a time, but for every answer we find, the ocean presents 10 more new mysteries. Even with modern radar, searching for a needle in this haystack is a daunting task, as the haystack itself is constantly moving and shifting with the current. Every ping and echo is a potential clue, a way to bridge the gap between the surface world and the silent, dark realm of the Puerto Rico Trench. This is the true heart of the triangle, a place of extreme depths and powerful currents that naturally create the conditions for the legends we know. But science has shown us that there is no magic here, only the awesome and sometimes terrifying scale of our planet's natural and physical features. Knowledge is our greatest tool, allowing us to traverse these waters with a clear understanding of the risks and the reality of the sea. As we look to the future, the Bermuda Triangle is no longer just a site of historical mystery, but a front line for the effects of climate change. A warming planet means warming oceans, and this added heat is the fuel for increasingly violent and unpredictable weather systems across the globe today. Rising sea levels and shifting currents are changing the very geography that scientists have been working so hard to map and understand for decades. The delicate balance of the Gulf Stream is being tested, with some models suggesting it could slow down or even shift its path in the future. Such a shift would make the waters of the Bermuda Triangle even more volatile, creating new and unexpected hazards for the ships of the next century. The air bombs and rogue waves we've discussed are likely to become more frequent and more powerful as the atmosphere holds more energy and moisture. We are entering an era where the unknowns of the triangle are being replaced by the unpredictables of a changing and warming global climate system. The question is no longer what happened, but how do we prepare? As we face a future where the ocean's rules are being rewritten by us. The Bermuda Triangle serves as a powerful reminder of nature's scale, a place where our technology meets its match in the face of raw power. Our pursuit of knowledge continues, driven by the need to protect ourselves and to understand the incredible planet that we all call our home. We have moved from myths of sea monsters to the reality of methane hydrates, proving that the truth is often far more interesting than the legend. While we may never solve every individual case, the pattern of the triangle has been revealed through the steady and patient work of scientific investigation. The era of superstition is ending, giving way to a time of data-driven understanding and a new respect for the forces that govern our world. Our relationship with the ocean must evolve, as we learn to navigate not just the water, but the changes we have brought to the entire planet. Collaboration is the key to solving the challenges ahead, as we use our collective intelligence to face the mysteries of the changing Atlantic Triangle. From this height, the boundaries disappear, and we see the ocean as one interconnected system that requires our care and our deep scientific understanding. The Bermuda Triangle is a chapter in our history, a mystery being solved, and a warning for the future we are all building together now. The ghosts of the past are fading, replaced by the clarity of the present, as we continue to explore the wonders of our amazing world. Thank you for joining us on this journey into the heart of the Bermuda Triangle, where science has finally shed light on the darkest of mysteries. The truth is out there, hidden in the waves and the wind, waiting for us to find it through the power of data and discovery.